Hello there and welcome back. In this lesson, we'll look into recursion. The term recursion actually comes from the verb recur. As you can see in this image, we have a window that is actually recurring and becoming smaller and smaller and smaller. This is actually what happens when you share your screen and you're still on the same window that is sharing the screen. For example, on Google Meet. So it's just a reflection of the same window. It becomes smaller and smaller and smaller. So this is the same thing you experience when you point a mirror to another mirror. You again get a recurring image of the mirror until a certain point where you cannot see it at all. Now, in some party clubs, they also do this optical illusion, whereby it gives you an illusion that it's an infinity hall, while actually it's just a single LED light and below it a mirror. So it actually creates that optical illusion. And if you're meeting it for the first time and you're a bit tipsy, it's easy for you to become sober again. So in this particular lesson, we will understand the concept of recursion. We will also try and understand the difference between recursion and iteration. We will see how to use recursion to solve problems and some of the problems that you may encounter when using recursion. These are called the Russian nesting dolls. So we normally have a doll nested to another one. So we have a bigger doll, and inside it we have a smaller doll, then smaller, then smaller, 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 and finally, the smallest there that has no other doll inside it. I hear that this is used to symbolize how mothers carry different generations through their pregnancies. We honor you, our dear mothers. So here, for example, if this was supposed to sing a song and each part has to sing some part. Now you see, in order for them to sing, you have to open up all the dolls. Then maybe the singing is beginning from the smallest, or from the biggest to the smallest. So this one will sing some part of that song, then this one, then this one, then this one, then this one. So everyone is handling some bit of it. That's just how recursion, for example, works. Now, in recursion, we have a problem, and that problem has a solution, and that solution or that problem can be subdivided into smaller instances. So when a problem has a solution that can be divided into smaller instances of the same problem, then we say that it's a recursive problem, and we use a recursion solution to handle it. Now, recursion in programming is actually when a function calls itself in order to solve a recursive problem. So that is what recursion is. Now, for example, if I can just explain this code here, we have a function called openDoll. openDoll. We are passing it a variable called nesting dolls. So we just want to demonstrate how, for example, we can implement the nesting dolls as a recursive function. Now, here we have what we call the base case. We're going to talk more about the base case, but generally we want to check if the nesting doll is equals to 1. That is, if we do not have any other doll inside that nesting doll, then we want to say, we want to print that we are done opening the dolls. Otherwise, we want to call the same function. You can see that they have the same name. So we are calling the same function, but this time we are passing it nesting doll -1 to show that we have removed one doll. So for example, if we had 5, if we passed 5 initially, then now we are going to pass 5 minus 1. So we're going to pass 4, then we pass 3, then we pass 2. After we pass 2, 2 minus 1 is going to be 1, and therefore it's going to meet this condition. 1 is equals to 1, and it's going to print done opening all dolls. So that's just an example of how we can implement the nesting dolls in a program. Now, recursion has several properties, some of which we've already mentioned. Number one is that it repeats the same operation multiple times, but with different inputs. Now, these different inputs are actually smaller on each step. The other thing that you've seen, for example, in the previous slide, is that we must have a base case, a base condition, in order to ensure that the recursion can stop at some point. If we don't do that, then we are going to have what we call an infinite loop. And that is going to be a problem, which we are going to understand a bit later in this lesson. So those are some of the characteristics or properties of recursion. So try out this challenge. You can pause if the timer is going too fast for you. Okay, wonderful. I hope you got that right. Okay, so here, I want you to understand that yes, recursion is when a function is calling itself, but here we are going to have a function calling another function, which in turn is going to call another function, which is going to print something, number 4. So this also just simulates what happens. What we want to see is what happens when a function calls another function, or when a function calls itself. So some data is going to be stored temporarily on a part of memory we call the stack memory. So that is what we want to see here. So here we have this function 1 that we are calling on line number 16 here. So once we call function 1, it's going to go inside the body and it's going to call function 2. So it's going to transfer the execution to function 2. So line number 6. When you get to line number 6, again, we are calling function number 3. So it's going to transfer the execution to line number 3. Then when we get here, we are going to call function number 4. Then it's going to transfer the execution to function number 4. And function number 4 is simply going to print the value 4. So how are we going to print these other values? These 3, these 2, and this 1. The stack memory is going to enable us to do that. So let's see how this goes. So when we call function number 1, when we encounter the call for function number 2, then we store the data where we left at, and store it in the stack memory. So that is what we are storing here. Then we go on to function number 2. So again, function number 2 is calling number 3. So again, we store where we've left at in function number 2 on the stack memory. Again, function number 3, we store where we've left at. We've left at number 10, line number 10. So we are supposed to begin in the next line. Then this one is going to call number 4. When we call function number 4, you realize that now we have an output. It's going to print 4. So function number 4 is not going to be added to the stack memory because we are not calling any function inside it. We are just printing the number 4. Now, what will happen is that, look what happens when I click next. So we are going to come back to the stack memory and check what is on top of the stack. So it's function number 3. So we go back to function number 3 and execute the next line, which is going to print 3, as you can see here. Then that is going to be removed from the stack memory. Now that removing from the stack memory is called popping, while adding items to the stack memory is called pushing. So we've just popped function number 3. We've popped it because we are done with that function. We don't have any other line to execute in that function. That function ends at line number 11. So we do not need it anymore. So we simply remove it from memory. So that's why we are removing it. Then we go on to function number 2. So now we are going backwards. Number 2 is going to print 2. Then again, we pop it. Oh, sorry. I pressed the wrong key. Then we pop it from the stack memory. Then we go to function number 1. It's going to print 1. Then it's the end of that function. So we pop it. We remove it from the stack memory. So generally, that is how a recursion works behind the scenes using the stack memory. So let's look at a true recursive method that almost performs the same functionality. So here we have a function called recursive method. We are passing to it a number, and as you can see here on line number 25, we're actually calling it and passing it a value 3. So we have a base case which is going to check if the number is less than or equal to 1. Is supposed to be equal to 1. So if it's less than or equal to 1, it's supposed to print finished. Otherwise, it's supposed to call the same function, and after calling the same function, it's going to print the number. So when it calls the same function, it should pass to it the number we passed minus 1. So we are reducing the problem on each call by 1. So let's go on and see how this will behave on the stack memory. So the first call, of course, we are passing 3 to recursive method. So it's going to be added there. Second call, it's now going to be, so for the first call, it's going to check, is 3 less than 1? It's going to produce false. So it's going to call recursive method 3 minus 1. So we are going to call recursive method and pass it 2, because 3 minus 1 is 2. Then we move on. So the next one here, 2 now, is going to check 2 is less than 1. No. So we call recursive method and pass it 2 minus 1. So that is what we are having here, 2 minus 1, which is 1. Then we come, is 1, as I said, sorry, I made a mistake. I made a mistake here. This was supposed to be less than or equal to. So this one is going to check, is 1 less than or equal to 1? Yes, it's equal to 1. So it's going to print finished. It's going to print finished. So that is what is going to happen next. So finished. You can see the output, finished. Then next, we are going now to remove. We are going to print 1. We are going to print the number here, the number 1. Then we remove the recursive method. We remove the recursive method from the stack memory. Then we are going to print 2 and remove 2 now. We're going to print 3, then remove 3. So we are printing 3 because it was stored in the stack memory earlier. So generally, that is how a recursive method operates in the stack memory. Now here, we want to look at, we want to compare and contrast between recursion and iteration. Now, iteration is when we loop through items. We can use a for loop, we can use a while loop or a do while loop. Recursion, on the other hand, is when a function is calling itself. So that is recursion. Now, we need to understand a few things about these two scenarios. Now, the example I've used here is not so good because these two are doing the same thing, but the iteration has fewer lines of code. But actually, in more complex situations, recursion is able to write solutions with very few number of codes. If you try to implement that with iteration, it becomes very vast. And the reason as to why it's able to do that is because, as you can see, recursion is actually reusing just the same code, reusing the same code by calling the same function. But if it was a for loop, for example, you would repeat code. So we are doing code reuse here. So that's one of the advantages of recursion, that it enables you to write shorter and more readable code. Advantage number two for a recursive function over iterative function is the fact that I said readable. Let's write with fewer number lines of code, and number two, readable. And number three, of course, is understandable. So it's easy to understand because it's shorter once you've written that particular code. On the other hand, recursion has its disadvantages compared to iterative solution. Number one, as you've seen, every time we do a recursive call, we use memory. We use the stack memory. So it uses more memory compared to iteration. And number two, because of the time we spend popping and pushing items on the stack memory, we spend more time compared to iterative solutions. So those are the disadvantages of recursive solutions compared to iteration. So iterations are more space efficient and more time efficient compared to recursive methods. While on the other hand, recursive methods help you write code or solutions with fewer lines of code that are more readable and understandable. So when do you use recursion? You use recursion when you can break down a problem into similar subproblems. Also, when you want to write short and more readable code, in traversing trees and graphs, you can only use initially recursion. Also, when implementing divide and conquer algorithms and when doing memoization using dynamic programming, you will need to use recursion. So we will look at tree traversal, graph traversal, and these other algorithms much later in this course. When to avoid recursion? When time efficiency matters. So for example, if you're writing a solution for devices that have limited processing capability, processing power, the CPU power, like smartphones, for example, then you will maybe want to use iterative solutions because of how much time it will take for recursive solutions to pop and push items to the stack. Also, when you want space efficiency, we've seen that it uses more memory, and therefore, for example, if you're implementing IoT solutions on Arduino boards or any other boards, you know, they have limited memory, so you'll want to use iteration instead of recursion for that particular matter. Okay, so as I breathe, I challenge you to attempt this question. All the best. Feel free to pause in case the timer is going too fast for you. Okay, so I hope you got that right. So how to implement recursion? We use 3 steps to implement recursion algorithms. Number one, we normally find a recursive case, which is how to subdivide the problem into smaller subproblems. That is what the recursive case is. Then the base case, when do we stop? when we do not have any other doll inside the nesting doll. So when the doll is equals to 1, that's the best case. Then we have the unintentional cases. Unintentional cases. So for example, for the Russian doll function, we don't want someone to give us a negative number, because we cannot have negative Russian dolls, and maybe you cannot also have 0. So those unintentional cases, we can use an if statement. If nesting dolls is equals to or is less than 0, then we want to print and say the Russian doll must be 1 or more, something like that. So those are the unintentional cases. Now, one of the interesting mathematical challenges that is solved using recursion in programming is finding the factorial of a number. So what is the factorial of a number? It's the product of all positive integers. All positive integers that are less than or equal to that particular number. And that particular number is normally denoted with an n. So that is what we call a factorial of a number. So it's normally written as n and an exclamation mark and read as n factorial. Now we have some rules. For example, 0 factorial is equals to 1 and 1 factorial is equals to 1. So we do not have a mathematical formula to show that. It's just a convention that is that in order for the factorial calculation to work. Now, how do we calculate the factorial of a number? For example, 2. So we simply take, so this is the solution and this is the answer. So we simply do 2, which is the number n, times 2 minus 1. 2 minus 1 is 1. So anytime we get to 1, we stop. When n is equals to 1, we stop. So this is just going to be 1 times 2. So we get the answer 2. Then we have factorial of 3, for example. So it's going to be 3 times 3 minus 1 times 3 minus 2. So 3 minus 2 is 1. So we stop there. So it's going to be 1 times 2 times 3, which is going to give us the answer, which is 6. Now, if you look at this one, the factorial of 4, and you look at the pattern, you see that this is the pattern we are creating, that n factorial is actually equal to n times n minus 1 times n minus 2 times until we get to 1. N minus something until we get 1, then we stop. So that is how we get our recursive case for finding the factorial of a number. It's simply finding a function that represents that particular solution. So that is our recursive case. So that is step number 1. We go to step number 2, the best case. When do we stop? We want to stop when we encounter a 1. If we do anything factorial and it gives us a 1, then we stop at that point. So that is our base case. Then step number 3, we find the unintentional case. So what happens when someone gives us a negative 2? How do we calculate? Our formula cannot handle this. So what we need to do is to ensure that n is always greater than or equal to 0. So we can use an if statement for that, a conditional statement. Also, we want to only have positive whole numbers. So what if we get 2.5? Again, our recursive function cannot handle decimals. So we need to ensure and enforce that n is an integer. So how do we do that in Python? I've written a function here called factorial. So this is the factorial function. It's having one parameter that we are passing to it, which is the number whose factorial we want to calculate. Then on the very first line inside the body of this function, line number 2 here, this is where we are implementing our unintentional case. So assert is a function in Python that takes in a Boolean condition that is going to result in a true or a false. So that is a Boolean condition. If it's true, then it's going to continue executing. Otherwise, if it's false, it's going to print out this as the error message, and it's going to stop the execution of this function. So if it's false, line number 3 is not going to be executed at all. Simply going to exit this function. So that is the assert function. So here we are checking if the number that we have been passed to is actually greater than or equal to 0, because we don't want negative numbers. And how to check if a number is an integer? This way, we have a function called int. You pass it the number, and then you equate it to the number. So this will return a true or a false. If it's not an integer, a whole number, then it's going to return false, and the error message is going to be printed. So that is the best case. That is the unintentional case. In the next line, line number 3, we're actually implementing our base case. So we are saying if the number we have is inside this list. This is called a list. This is how we do a list in Python. So the list has 2 items, 0, 1. So if this number that we have in this variable is a 0 or a 1, we want to stop the execution of this function by returning 1. Else, so this is our base case. Now this is our recursive case. So we want to say number times number minus 1. And now we are calling the factorial function again. So you see they have the same name, the factorial function. So we are calling factorial again. So we are simply saying that we want to multiply number times number minus 1. So number minus 1 again is going to call number minus 1 until we get to a 0 or a 1. So let's see how this is going to work out in the stack memory. So what we are doing is that we are calling factorial and passing it 3. Then we want to print the final results. So let's see how this is going to happen. So if we call 3, then it's going to be 3. So 3 is not in this list, is not a 0, it's not a 1. So we are going to call factorial again. So factorial this time, sorry, I pressed the wrong key again. So factorial this time is going to minus 3 minus 1. So factorial 2, then it's going to minus 1 again. So factorial 1. When we get to factorial 1, it's going to check this condition, the base case, 1 in 0 or 1. Yes, it's there. So it's going to return 1. So by returning 1, we are going, we are going to have 1 as the results of factorial 1. Then we remove that function from the stack memory. Then factorial 2 is going to calculate the factorial of 2. Then we get it out of that memory stack. Then we calculate factorial 3 and remove it. And now we have the answer, which is 6, because we are simply multiplying 1 by 2 by 3 at each process as we remove those items from the stack memory. So generally, that is how this works. I hope you've been able to understand it. If you have a comment or a question, please feel free to put it on the comments. Other than factorial number, the other problems that are solved using recursion is the Fibonacci. The Fibonacci sequence. So the Fibonacci sequence, again, some flowers make a perfect Fibonacci sequence, like the sunflower. You can see that is actually making smaller problems like that. Then we have this one here, which I was missing. And then we have this one. Then we have the bigger one. So look into that before we implement it during our practical session. Then, of course, the next one here is called the Tower of Hanoi. It's a very interesting game which I didn't know about. So it actually has 3 towers, and this one is the destination tower, which is called the Tower of Hanoi. So you're supposed to take you're supposed to take all these wheels, let me call them wheels, to the Tower of Hanoi, and they're supposed to be arranged in this exact order. Yet we have rules. For example, you can only shift one wheel at a time, and you cannot put a bigger wheel on top of a smaller wheel. So it's kind of a challenge. I want you to go and search about this game and maybe try and play it. I'm sure there must be some implementation of it online. So just have a look at it. Then maybe we'll have to challenge ourselves to implement that particular solution during our practical. So another challenge for you. So go on. Feel free to pause as usual in case the timer is going too fast for you. Okay, so I hope you got that right. Now, we have a community that has been so helpful for so long called Stack Overflow. When I started programming and I was really struggling and learning, I've always run to Stack Overflow to find solutions. It's a community of developers, the largest community, by the way, where people explain to each other solutions to challenges they experience. So when you experience a challenge and you've searched about it and you can't find an answer, you post it on Stack Overflow, then people respond. But actually, I didn't know that they had borrowed this name from a concept in computing called Stack Overflow. What's more interesting is that actually their logo actually explains what Stack Overflow is, which is you have a stack, which has a limited size, then you try to add in items to it. So that is how we get the overflow, when you try to add items to the stack, because it's already full. So that is what we call Stack Overflow. When you exceed the size of your stack, then we have a Stack Overflow. Okay. Causes of a Stack Overflow: when you don't have a base case, then you have an infinite loop. Remember, this is related to recursion. So if you've implemented a recursive function and you do not have a base case, then you have an infinite loop. An infinite loop will definitely fill the stack. When your base case is incorrect, you're going to have an infinite loop again. The last one is the deep recursion. So we have something called the recursion depth that, for example, Python has implemented. So in order to avoid Stack Overflow, Python allows a maximum of 1,000 items in the stack memory. So if it goes beyond that, then it throws you an error. So when you have a deep recursion, it means that you are giving your recursive function a very large input, and therefore it has to do so many loops, maybe 10,000, maybe 1,000, maybe 1,000,000. So if you do that, you're going to have Stack Overflow. So let me just demonstrate to you here how that can happen. For example, in Python, if you want to find, for example, a factorial of a number 1001, this is going to give you an error. because you can only do a maximum of 1000 recursive calls. So we will go to 1000, then 999 because you're decreasing by 1. So we're going to do that until you get to 2. And now when you try to do the last one, look what happens. Stack overflow. It can't fit. The stack is full. So when that happens, you get a recursive error. So this is really just an implementation in Python to ensure that you don't have stack overflow, because it's a problem that is not very easy to troubleshoot and will keep on crashing your program and probably the entire operating system. So to ensure that this cannot happen, programming languages, advanced programming languages like Python, implement what we call a recursive limit. So it's important for you to know that you can actually extend this recursive limit. There's a function to do that in Python, for example. Okay, so one interesting application of recursion that we use in our day-to-day lives is actually the implementation of the file or directory tree. So when you want to search for a file, we use recursion to do that. When you want to calculate the size of a folder and the items that are in it, it's going to recursively visit each item that is in that folder and calculate its individual size, then add them up. When you want to display the directory tree, like what I've done here on this screenshot, when you want to copy or delete folders that have items in it, then again, we're going to use recursion. Now, this is not the only application of recursion in industry. So if there's any other that you know, please feel free to put it down on the comment section below, and I'll appreciate it. Okay, so that is the end of this lesson. We've learned that recursion is when a function calls itself in order to solve a problem whose solution can be divided into smaller subproblems. We've also seen that the components of a recursive algorithm includes a recursive case, a base case, and the unintentional case. We've seen that you can use recursion. You can use recursion to solve problems such as the factorial of a number or the Fibonacci sequence, or to traverse data structures like the tree and the graph data structures. We've mentioned advantages and disadvantages by comparing recursive functions to iterative solutions. So one of the problems, for example, with recursive functions is it's not very friendly when it comes to the usage of space and also time. And it can also run into problems when you exceed the stack limit. So you run into stack overflow problems. And we've of course learned about stack overflow, and we've understood what it is. So in the next lesson, we will have a look at 3 recursion interview questions using Python, and the IDE we are going to be using is Visual Studio Code. So if you don't have it yet, please make sure you install it. So see you in the next video. Thank you for staying to the end. Bye bye for now.